An array A where indexes are 1 to n contain elements 0 to n. Means what the meaning? In this array which contain n indexes, values are 0 to n means n plus 1 element, except one element, every element is there, he is saying. Then how much time it will take to determine the missing integer? How can you find out? How can you find out the missing integer? So if you want, I will give one small example also. Let me check here. Let me check. Array name is A. One, two, three, 4, 5, 6, 7, 8. Right? So what is the answer? N value 8. Array name is A where this array contains 8 elements. Indexes are 1 to 8, but values are 0 to 8. One element is missed out. Let me check here. So indexes are 1 to 8, values are 0 to 8. One element is missing. I am writing that missing element also. Let's check here. 7, 0, 8. So array name is A which contain 1 to 8 indexes. Values are 0 to 8. Except one person, everyone is there. Right? Find the missing person. Find the missing person. If you want, you can check. In this array, if you see the range, right? Minimum is 0 is there, maximum 8 there. Right? I think, but indexes are only 8, but values are 9. Except one person, all are there. Can you help me now? Who is the missing person? If you want, you can check. I think 0 there, 1 there, 2 there, 3 there, 4 there, 5 not there. I think answer is 5. How to find out the missing number? Missing number here 5. How will you find out? How will you find out? Missing number is 5. How will you find out? There may be many ways, right? Let's see one by one. There may be many ways. Let's see, right? Who is that? Now listen. One answer is going to be, careful listen. One answer is going to be, because of you know that, right? Elements are 0 to 8. Elements are 0 to 8. You know that, right? One answer. If you want to find out the missing number, one answer is going to be like this one. What is the answer? Take one array. Array name is going to be, right, you can write whatever name you want, B. Take one array name is B. B contain indexes, right, 0 to 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. Take one array, name is called B, where B indexes, if you see, 0 to 8. 0 to 8. Now what you have to do one by one? Initially these all are minus 1. Take one more array, name is called B, where indexes are, right, what are the values here? 0 to 8. But here indexes are 0 to 8. So B values are initially all are minus 1. Now you have to do like this. How? Right? So this is the way. Can you help me now? What is the A1? Just go to the A, A1, A of 1. What is the answer? 7. If A of 1 is 7, just go to the B7. Right? In the B7, minus 1 there. Then keep 1. What is the meaning? Indication that, right? 7 is came one time. 7 is came one time. Initially minus 1 means not came at all. Right? When you keep 1, indication that 7 came one time. My goal is what? Which element is not came? I have to find out. Now in the similar way, those people who are troubling, can you help me? What is the A of 2? A of 2 is 0. A of 2 is 0. Take that 0. B of 0 check. I think minus 1 means not came until now. It the first time came, so 1. Next one, A of 3, 1. Just go to the B of 1, 1. Next one, A of 4, 6. B of 6, 1 you keep. Next one, A of 5, 4. B of 4 you go. A of 5 is 4. Then go to the B of 4, 1. Next one, what is the answer? A of 6. What is the answer? 2. B of 2, 1. Indication that 2 came one time. Next one, A of 7, 3. B of 3 you go, 1. Indication that 3 came one time. Next one, A of 8. What is the answer? 8. So, B of 8 you go. Just make 1. Just I think I done one scan here. Whenever I am scanning, right, whichever element is came, that particular index make it as 1. Right? So whichever element is came, that particular index make it as 1. Indication that it came one time, it came one time. So I think one scan you done, order of n time. Afterwards, right? B array you scan one more time. Right? One scan for marking, one more scan. Please verify, is there anyone still minus 1? Yes, is still minus 1 there. That indication that this person is not came. This is the one, right, who is not available in the given array. So what is the answer? I think minus 1 means he is not came one time also. So answer is 5. Now can you help me now to this algorithm? What is the time? Scanning will take n time. One more scanning is 1 more n, totally 2n. Totally 2n time, right? Time complexity is big O of n. Now what the problem is asking? An array A where indexes are 1 to n, values are 0 to n, except one element everyone there, how much time it will take to determine the missing number? What is the answer? Order of n. At least one scan required. At least one scan required. If you don't scan, how will you know that who is there, who is not there? One scan required. But maybe I done two scan. One scan for this one. One more scan is going to be. One more scan is going to be. What is the answer? Is there anyone who is not still came? Right? I think -1 means not came. So that is the answer. Two scans you done 2n, right? Asymptotically order of n. And one more. The problem with this algorithm is going to be two scans. That is okay. Right? But asymptotical order of n, that is fine. But you are taking some extra space also. Extra space, right? B array you are taking extra space. So I think the extra space is n, right? N plus 1 maybe. Extra space is n time. Right? See this one. This is the time complexity. This is the extra space. So to this problem, what is the time complexity? Order of n. What is the extra space? Order of n. One more algorithm there. One more algorithm is there. It is very simple also. See this algorithm also. One more algorithm. To solve this problem, one more algorithm there. What will you do is, this is the A array which contain how many slots? 1 to 8 slots are there. This is the A array which contain 1 to 8 slots. Means 8 slots are there. Elements are 0 to 8. That is okay. Right? Now what will you do is, right? You have to do that like this one. Because of you only saying that 8 elements are there. You only saying that 8 elements are there, right? Now what will you do? Sum of 8 natural numbers find out. What is the answer? 8 into n plus 1 by 2. 8 into 9 by 2. Which will goes to how much? I think 2 4s 8. 4 9s 36. Sum of n natural numbers you do, you got 36. Right? Now what will you do is 36 minus sum of 8 natural number, 36 minus, right? Now these all the people sum you delete. Can you help me now? Can you add all of them? 7 plus 0 7 plus 1 8 plus 1 8 8 plus 6 14 14 plus 4 18. I am repeating once again. 7 plus 1 8 8 plus 6 14 14 plus 4 18 14 plus 4 18 18 plus 2 20 20 plus 3 23 23 plus 8 31. So 31. What is the remaining value? 5. So I think 8 numbers are you are saying sum of 8 natural numbers find out 36, right? From that total sum you delete 31. If you do that 5 is came, so 5 is the missing number. Totally 8 numbers are there, right? Range is 0 to 8, right? So some people are saying that sir totally 8 numbers only there. That is the reason sum of 8 natural numbers. From there, total sum you delete, you will get the missing number. Now some people are asking, this is the second algorithm. One algorithm is like this, one more algorithm is like this one. Sum of n natural numbers find out minus total sum you delete. Can you help me now? Sum of n natural number to find out how much time? Constant time, because formula, this formula will take constant time. Next one, adding all will take n time. Adding all will take n time. Next one, subtraction will take constant time. Everyone, loops only will take time complexity. I think it is a loop because you have to add all the people. Formula will take constant time. Adding all one loop required order of n, right? I think subtraction will take constant. So overall time if you observe 1 plus, see this one, constant plus n. What is the answer? N time. Right? Every case. And one more, the advantage with this algorithm, there is no requirement of one more array. Right? This is also, listen, this algorithm required one scan only. This algorithm required two scans. One scan for who is came. One more scan is for who is not came. One scan for who is came. One more scan for who is not came. Two scans required. But here only one scan to find the sum. Right? Or afterwards nothing there. Both will take time complexity same asymptotically. Right? Mathematically maybe he will take more, he will take less. But asymptotically both are the same time. But space if you observe extra space here n, here extra space constant, right? 1 or 2 local variables. So order of n time every case, right? Order of 1 extra space. So this algorithm is better, right? Please be careful. But anyhow, he is asking time complexity for this problem. Answer for question number 1, answer is going to be A. Question number 1, answer is going to be what is that? A. A is the answer. Two algorithms I said it. The first algorithm, that is the second algorithm. Second algorithm is best one. Simply sum of a natural number find out, from there total sum you delete. So let's go to the next one. Question number 2. Question number 1 over question number 2. I think what is asking, merging two sorted subarrays each of size m and n will take how much time? Merging two sorted subarrays each of size m and n will take order of m plus n time every case. Right? Merge algorithm you know very well. Time complexity is going to be order of m plus n every case because of moves. For the question number 2, what is the answer? I think C. What is the next one? Question number 3. Question number 3, if you observe, right, there is a one permutation a1 to an of n distinct integers. An inversion is a pair ai aj such that I less than j and ai is greater than aj. You know inversion very well. In a permutation of a1 to an of n distinct integers, an inversion is a pair ai aj such that I less than j and ai is greater than aj. So permutation, see this one, right? One permutation is given. In that permutation, you can say a pair ai aj is said to be a inversion, right? Condition you know very well, right? Fine. Now is asking in that, right? So question number 3 is like this one. If all permutations are equally likely, what is the expected number of inversions in a randomly chosen permutation of 1 to n? If all permutations are equally likely, what is the expected number of inversions in a randomly chosen permutation of 1 to n? Right? So now is asking what is the expected number of inversions in a randomly chosen permutation of 1 to n. Right? See the answer for this. See the answer. Listen everyone. Listen carefully. Listen. So there is a one permutation. See this one. A1, A2, A3, and so on. An. There is a one permutation, right, with n numbers. A1 to An, right? One permutation is there. Right? Can you help me one small? From this, you only say how many pairs will be there. From these n numbers, how many pairs will be there? You know very well. Out of these n people, taking 2 people, what is the answer? NC2. These many pairs, NC2 pairs are there. Right? This array contains n numbers. Right? From these n numbers, you have to select pair. How many ways are there? Out of n, selecting 2. NC2 pairs are there. NC2 pairs is nothing but what is the answer? NC2 means what is the meaning? N into n minus 1 by 2. These many pairs are there. From this array which contain n elements, selecting 2 people NC2. So NC2 pairs are there, which is nothing but n into n minus 1 by 2 pairs are there, right? And one more thing I want to ask you. If you take any pair, right? So if you take the ai aj, what is the answer? If you take ai aj, it may be a inversion, it may not be a inversion. 2 choices. It may be a inversion, it may not be inversion. 2 possibilities are there. It will become inversion. Probability becomes 1 by 2. Take any pair. It may be inversion, it may not be inversion. Probability of it will become a inversion, right? 1 by 2. So to take any pair, ai, aj you take. Take any pair. It may be inversion, it may not be a inversion. 2 possibilities. So that pair becomes a inversion. What is the probability? Possibilities are it may be inversion, may not be inversion. Right? The probability of that will become inversion 1 by 2. Right? These many inversion. Right? These many inversion. See this one. These many pairs are there. Every pair may be inversion, may not be inversion. So that pair become inversion. Probability is going to be 1 by 2. 1 by 2 into, right? These many pairs. These many pairs are there. Right? Now if you take any pair in this, that may be a inversion, that may not be a inversion. So probability of that pair becomes inversion 1 by 2. So 1 by 2 into n minus 1 by 2. Right? So it is going to be n into n minus 1 by 4. Right? This is the answer. These many pairs are there. Every pair may be inversion, may not be inversion. So 2 choices. But if you take any pair, it will become inversion. Probability is 1 by 2. 1 by 2 into n minus 1 by 2. So n into n minus 1 by 4. This is the expected number of inversions. Just to find out the pair, every pair having 2 choices. So every pair having 2 choices. The probability of that pair becomes inversion is going to be 1 by 2. 1 by 2 into number of probability into number of possibilities. So finally 1 by 2 into n minus 1 by 2, which is going to be n into n minus 1 by 4. That is the answer for this problem. So for the question number 3, what will be the answer? B. Question number 3, answer is B. Right, now go to the next one, question number 4. Right, question number 4. What they are saying? What would be the worst case time complexity of the insertion sort algorithm if the inputs are restricted to permutations of 1 to n with at most n inversions? With at most n inversions. Now let me check one small line. Carefully listen. Question number 4. Carefully listen. See this one. One, two, three, 4, 5, 6, 7. Next one. See, make sure that everyone listen. 10, 20, 30, 40, 50, 60. Right? So I think if you observe clearly in this one, right, indexes are increasing, values also increasing. There is no inversion. Right? In this array, if you observe clearly, indexes are increasing, values also increasing. Right? There is no inversion here. Everyone know. Now see the answer. Here index is, listen everyone now. Here. Here if you see, right, if you see this one, here index is more, but value is less, it is an inversion. Here if you observe clearly, index is more, but value is less, this is called inversion. Can you help me one small line now? Right, in this one, this array contains 7 elements. How many inversions are there? This array contains 7 elements. How many inversions are there? What is the answer? For the first element, right, this is inversion. For the second element, it is an inversion. For the third element, it is an inversion. For the fourth element, it is an inversion. For the fifth element, it is an inversion. For the sixth element, it is an inversion. Right? Listen everyone now. Seventh element is inversion to everyone. This array contains 7 elements. Number of inversions are 6 there. This array contains 7 elements, but number of inversions are 6 there. What is the meaning? Array contains n elements. At most n inversions are there. Array contains 7 elements. Almost 6 inversions are there, means almost 7 inversions are there. Now I am repeating once again. There is one array, in that array n elements are there, and one more thing is at most n inversions are there. Meaning is there is an array which contains n elements, and in that array at most n inversions are there. At most means maximum n inversion. It may be less than that also. Either n elements where number of inversions are either n or less than n. Here what is the answer? 7 elements are there. Number of inversions are 6 there. What is the meaning? At most 7 inversions are there. Try to remember in any array, right, n elements are there. Number of inversions are there. Number of inversions are at most n. Indication that array is almost sorted except 1 or 2 people. Array is almost sorted. If you want, you can check. Except last element, everyone is sorted. In the given array, at most n inversions are there if anyone say to you. Indication that array is almost sorted. Means except 1 or 2 element, that array is sorted. You know very well. If array is almost sorted or already sorted, right, insertion sort algorithm is better to sort that. If array almost sorted or already sorted, insertion sort algorithm is the best one. What is the reason? For that kind of arrays, insertion sort is better. Now this array you sort using insertion sort, right? It will give you the best answer. Let me ask you, sort this one using insertion sort. What will happen? Right? Insertion sort everyone now. 10, 20, no problem. Right? 30, 20, no problem. 40, 30, no problem. 50, 40, no problem. 60, 50, no problem. Next one. 5, 60, problem there. Swap 60 here, 5 here. Again 50 here, 5 here. Again 40 here, 5 here. Again 30 here, 5 here. Again 20 here, 5 here. Again, right, 10 here, 5 here. I think for the only last person problem, remaining all the people no problem. What is the meaning? Until last person, see this one, n elements are there, assume that. Until except last person, remaining all the people, almost like n minus 1 time. For everyone is constant, like that n minus 1 people, n minus 1 constants, n minus 1. Only for the last one, right? I think last one will ask every person, right? One more n. Totally, what is the answer? 2n approximately. So time complexity order of n. Try to remember, in the given array, at most n inversions are there, indication that array is almost sorted, indication that insertion sort algorithm you can apply, indication that, right, insertion sort algorithm will give time complexity to sort that kind of array, order of n time. So to this problem, what is the answer? Order of n is the answer. For the question number 4, answer is D. Question number 4, answer is D. What are the keywords here? At most n inversions means array is almost sorted, means, right, insertion sort is better. Why? For that insertion sort will give best performance, order of n time. So time complexity, order of n. If you apply some other algorithm like merge sort, n log n it will take. If you apply quick sort, maybe, right, quick sort if you apply, because of it is almost sorted, quick sort may take n square time, right, because of it is almost sorted, apply the insertion sort algorithm, which will take order of n time, because for that kind of array insertion sort algorithm will give best performance, order of n. For the question number 4, what is the answer? 4th option. Right, go to the next one. Question number 5. Question number 5, this is already there in your notes, right, it is already there in your notes also. Answer is going to be C. Question number 5 is, answer is going to be C. Next one, question number 6, it is there in your notes already. That is the reason I don't want to waste your time, so I am going to the question number 6 now. Question number 6, what is the answer? It may be already there in your notes also. If you want to, only for namesake I will explain. Can you help me now? 2047. Next, 15:8. Next, 9:4. Next, 40:30. Next, 12:70. Now, right, what he is asking, right, what is the output after second pass of the straight two-way merge sort algorithm? What is the meaning? Two people merge. That is the meaning of straight two-way merge sort algorithm. Two people merge. What is the answer? 20:47. This is 8:15. This is 4:9. This is 30:40. This is 12:17. This is output after first pass, right? You want output after second pass. So what is the answer? 8:15, 20:47. This one 4:9, 30:40. This one 12:17. This is output after second pass. Okay, read this 18:15. Right, I am reading once again. Right, read this one. 8:15, 20:47, 4:9, 30:40, 12:17. So what is the answer for the question number 6? Question number 6, B is the answer. It is there already in your notes also, right? That is the reason roughly I said. What is the meaning of straight two-way merge sort algorithm? Straightly take two people and merge it. If you do first time, right? If you do the first merging, first pass output. If you do second time merging, second pass output. So for the question number 6, answer is going to be second option. Go to the question number 7. Question number 7, if you see, right, is asking in the given array of n elements to find out the inversions, how much time it will take. You know very well. What is the answer? We are already done. We are already done, right? In the case of the divide and conquer, we are already done. To this problem, answer is going to be B, n log n. To find out inversions in the given array, how much time it will take, right? N log n time using divide and conquer. Using divide and conquer. Without divide and conquer, n square. Using divide and conquer, n log n. For the question number 7, what is the answer? B. Go to the next one now. Question number 8. Question number 8. Question number 8, I think this problem also we done many times, right? Question number 8, it is there in your notes also. B is the answer. Question number 8, B is the answer. What is the answer for this one? Big O of Kn log K. It is there in your notes. Many times we done. Question number 8, answer is B. Question number 7 also B. Question number 8 also B. See the question number 9. See the question number 9 now. I am reading. Suppose there are 4 sorted lists of n by 4 elements each. N by 4 elements is 4 sorted lists, each of size n by 4. Let me write now. 4 groups. 4 sorted groups are there. Each of size n by 4. That's okay. Next what is asking? If we merge these lists into single sorted lists, so you have to merge them into single sorted. If we merge these lists into single sorted lists of n elements, right, for the n is equal to 400, the number of key comparisons in the worst case using efficient algorithm is using efficient algorithm. Can you help me? N is equal to 400, right? N by 4 means 100. What is the meaning? So there are 4 groups. Each group contain N by 4 elements. I think N value 400. 400 by 4, how much? 100. So every group contain 100 elements. And one more, they are already sorted also. You want to make these 4 groups as one group, right? Means you have to merge. While merging, maximum number of comparisons is asking. Worst case means what? Maximum number of comparisons they are asking, right? How to do that? So nothing there. See this one, merge these two first. Merge these two also. If you merge these two, so what is the answer? If you merge these two, what is the answer? If you merge these two, right, totally 200 elements will come, it's okay. But comparisons, if you see worst case, right, what is the answer? If you remember, while merging, number of comparisons are going to be, right, less than number of moves. Moves will be, all elements will move. 200 moves, it's okay. But comparisons are, what is the answer? 100 plus 100 minus 1. What is the answer? Comparisons became 199. But elements are 200. Again, when you merge them, here also 200 elements will come. But comparisons are going to be 199, right, in the worst case. Can you say best case? Best case is going to be minimum of these two. I think 100 only will come. Best case comparisons are 100, worst case comparisons are 100 plus 100 minus 1. But moves are in every case 200. It is also same. Best case comparisons are 100, worst case comparisons are 199. Moves are always 200. Can you say, until now how many moves are there? Until now. Sorry, until now how many comparison? 199 for first time, 199 second time. Now, let's merge these two also. So what is the answer? Total elements will become 400, it's okay. But if you see the number of comparison, what is the answer? 200 plus 200 minus 1. What is the answer? 399. So let me write that also. It is the first merging, it is the second merging comparison, it is the third merging, 399. Right? Add all of them. 9 3 is 27, 9 3 is 27, 29. Right? 9 3 is 27 plus 2, 29. Next one plus 2. What is the answer? 2 plus 3, 5. Right. So 3 9s 27, 2. 3 9s 27 plus 2, 29, 2. 5 plus 2, 7. 797. Right? 797 comparisons are required in the worst case. 2 2 I merged. 2 2 I merged. Some people are asking, sir, can't you merge? Can't you merge all the 4 people at a time? Can't you merge all the 4 people at a time? If you merge all the 4 people at a time, it will become more comparisons. If you want, you can verify. It will become more comparisons. So anyhow, to this problem, 2 2 I merged it. Total number of comparisons in the worst case is going to be 797. 797. First time merging, 199 comparisons, worst case. Second time, 199. Third time, 399. Total 797. Right? Totally 797 comparisons are required in worst case. Right? So for the question number, what is the question number? Question number 9, answer is going to be 797 comparison in the worst case. Can you help in a best case? What will happen? Best case. Right? Here 100 will come, best case. Here also 100 will come, best case. Here 200 will come. Totally 400. 100 plus 100 plus 200, which will goes to 400. 400 is the best case comparison, right? Next one, worst case comparisons are going to be 797. 797 worst case comparison. Can I say moves how many? Every time same moves will come. 200, right? 200 moves here, 200 moves here. It is the 400. Total how many? First time 200, second time also 200, third time is 400, which will goes to 800. Moves are always bigger, right? It is every case same only. So moves are 800 every case. Comparisons are 797, right? Worst case comparison, right? Best case is going to be only 400. But anyhow, for our problem, right? This is the answer. For the question number 9, that answer is going to be 797. Right, see the question number 10 here. Right, see the question number 10. I am starting. Let me read the question number 10. Assume that a merge sort algorithm in the worst case takes 30 seconds for the input size of 64. Which one of the following most closely approximate the maximum input size of a problem that can be solved in 6 minutes? Listen now. It is very, very important one. Same kind of problem. This may be for merge sort. Similar kind of problem is asked in the previous paper many times. Right? The place merge sort replaced by maybe quick sort, maybe heap sort, maybe bubble sort. Please try to learn the question number 10 right? This is came many times, it will be really useful to you also. How it will be solved, I will explain to you. If you are fine with the question number 10, many problems you can solve, right? I am starting now. Question number 10, how to solve. See this one. Question number 10 belongs to which sorting algorithm? Merge sort. Carefully listen. It is very simple also. Question number 10 belongs to merge sort. Whatever he is saying, right? Merge sort. Question number 10 belongs to merge sort, it's okay. Before going to the original problem, whatever you know about merge sort, let me write. Question number 10 belongs to merge sort. Before going to the actual problem, whatever you know about the merge sort, let me write. I am writing here. See, major line, I am writing. See this one? Merge sort. Using merge sort to sort n elements. Using merge sort to sort n elements, how much time it will take? N log n base 2 time it will take. Which case? Every case. He is asking worst case, but interesting thing is every case is same. If he say best case also same answer. If he say worst case also same answer. Listen, before going to the actual problem, what you have to do is, about merge sort, whatever you know, you write first. What are the merge sort we know? Merge sort algorithm for sorting n elements will take n log n time every case. Now next one, n log n time every case means which is nothing but n log n base 2 operations. Everyone, it is taking some time means what? Some operation. Every operation will take some time, right? So some n log n operations are going on. Please be careful. Merge sort for n elements taking n log n time means n log n operations are going on. You know very well which operations they are. In the merge sort, major operations are moves only. So n log n moves are going on. Merge sort algorithm, n element sorting will take n log n time means n log n base 2 operation. Which case? Every case. He is asking best case or worst case? He is asking worst case. Best case also same because merge sort every time, right? It will take n log n time. This is the information which I know about merge sort. Merge sort for n elements, I am repeating finally this is the final line. Merge sort for n element sorting will take n log n time, which is nothing but n log n operations every case. This is the information which I know about merge sort. Let's go to the actual problem. If you come to the actual problem, what he is saying is, to sort 64 people using merge sort, it is taking 30 seconds. Right? Let me try this one. See this one? This is the thing what he is saying in this problem. To sort 64 elements. 64 element sorting. Using merge sort. How much time he took? 30 seconds time he took. Which is nothing but, listen, 64 element sorting, it took 30 seconds. 64 element sorting, actually merge sort will take how much time? Let me write now. 64 into log 64 base 2 operations will take 30 seconds. Which is nothing but 64 into 6 operations will take 30 seconds. Finally, one operation will take how much time? 30 by 64 into 6 seconds. This is the one operation time, right? So, he said something, based on that I got. Next one, he is saying something else also, let's check. Which one of the following most closely approximates the maximum input size of a problem that can be solved in 6 minutes? He is saying that which one of the following closely approximate the maximum input size of a problem that can be solved in 6 minutes using merge sort? See the next one. Let me write now. See this one. Make sure that listen what he is asking. Assume X input size can be sorted using merge sort in 6 minutes. Assume that. Assume X input size can be sorted using merge sort in 6 minutes. Right? Now, if at all it is true, right? X input size you can sort using merge sort in 6 minutes. That means this is the meaning. X into log X base 2 operations will take 6 minutes time, which will goes to 6 into 60 seconds. Right? So finally what is the answer? X into log x base 2 operations. Can you say one operation time? I already done. 30 by 64 into 6 seconds. Right? This is equal to this much time. Next one, if you simplify further, what is the answer? X into log x base 2 is equal to, what is the answer? 6 into 60 seconds by 30 into 64 into 6. Right? Simplify whatever is possible. I think 32s, which will goes to 12 into 64 into 6, which will goes to 72 into 64. So can you help me now? X into log x base 2, right, is equal to that much, right? Can you say for which x value both are equal? In the option, whatever is there you can find out. Otherwise you can slowly substitute by yourself. It is up to you, right? I still remember, replace x by 512. Replace x by 512, right? This problem can be solved, right? If you replace x by 512, what is the answer? 512 into log 512 base 2. What is the answer? 512 can be done 2 power 9. 9 is equal to 72 into 64. If you want, you can check both are equal. So x value 512. So can you help me? What is the answer? X value 512. What is the meaning? Right? This is the meaning. Right? See this one. 512 input size can be sorted using method sort in 6 minutes. This is the way of solving. Which x value left and right both will be equal? X value 512 both will be equal. In the option whatever is there, substitute one by one. If at all options are not there, numerical value assume, you substitute by yourself. Slowly one by one number you substitute, you will get the clarity. You may say that, sir, it will take more time. For all the people same time. Right? This is the way. If anyone go some other shortcut, do whatever way you want without changing the meaning. Again I am asking you, question number 10. Right? About method sort, I know the story. This is the only story which I know about method sort. Question number 10, about method sort, I know the story. Next one, what he is given this. And what he is asking, this one. Right? So I think some people are asking, in this one where you utilize, I think this one I utilized here. Next one, where you utilized this one only, indirectly, directly, this one I am using everywhere. Right? Finally, what is the x value? 512. And one more. He is asking for worst case. Right? If at all best case also same, because method sort every time same story. If at all quick sort, worst case n square. Everything, listen everyone, all sorting algorithm, this problem can be asked. Please be careful. Only name they will change. Then they will indirectly, directly you should know only one thing. What is the answer? That sorting algorithm. Worst case will take how much time? Best case will take how much time? Like that you can handle. So this is a nice problem, please you take care. Question number 10 is a nice one. It has taken a lot of time also to explain. It is really useful to you. That is the reason I took a lot of time to explain this. This is the question number 10. Let's go to the question number 11. Go to the question number 11 now. Question number 11, if you see, which one of the following is application of divide and conquer? What is the answer? D. Question number 11 is going to be D. Right, now go to the next one. Question number 12. Question number 12, if you see, what is the answer? The worst case time complex quick sort n elements with the median is selected as a pivot. If you take the median as pivot, it will divide exactly two parts. Is asking worst case, it will take always n log n time. Because the median you are selecting as a pivot. What is the answer? C. Question number 12, answer is C. Question number 13. Question number 13 is asking, randomized quicksort is the extension of quicksort where pivot is chosen randomly. What is the worst case? Randomized quicksort also, worst case will take n square time. What is the answer? C. Question number 13, answer is C. Next one, question number 14. Question number 14, right? Answer is going to be C. Question number 14, answer is going to be C. Just a type. Given two arrays A1 to AN. Given two arrays of numbers A1 to AN. Just type in the Google or YouTube. You will find out one algorithm also. Right? Please go through it. Question number 14, answer is C. If you type in the YouTube or Google, just type first line. Given two arrays of numbers A1 to AN. You will see one for loop is there. In that algorithm, one for loop is there. This may be your homework. Please be careful. In the entire workbook, every question I explained. This may be your homework. It is there in the YouTube also, one nice video also there. Given two arrays of numbers a1 to an. Just type that, you will see is similar algorithm, similar problem. Answer is order of n because one loop is there. Please check. Question number 14, answer is C. Question number 15. Question number 15. Come to the question number 15. Question number 15. Question number 15, if you observe clearly, it is there in your notes also. It is a selection algorithm. Not selection sort, selection algorithm. Can you help me? Selection algorithm, what is the major one? Partition. Selection algorithm, major one is partition. He said something about partition, you have to take care. Let's see rough diagram. Let's see rough diagram. See everyone here, 25, 31, 18, 15, 90, 19, 80, 16. Right? Now, if you apply partition algorithm, what is the output? Pivot element will go to correct place, less than pivot one side, more than pivot other side. Who is the less than pivot? Write whatever order you want, 18, 15, 19, 16. Who is the more than pivot? Who is the more than pivot? More than 25, 31, 90, 80. And one more thing I want to ask you one small line. Can you help me now? So if you observe clearly, to this kth smallest element, see this one, to this kth smallest element algorithm, what is the input? See the program correctly, not partition algorithm. Kth smallest, right? Kth smallest. To that algorithm, what is the input? Int a of, means one array is input. Next one, int n, number of elements. Int k, kth smallest element. 3 parameter array, number of elements in the array, and kth small, right? And int k means k value 5 means fifth smallest element, like that you want to find out. But see, nowhere is mentioned in this array what is starting index, nowhere mentioned. But if you see the program, if you see the problem starting, right? So with the following function declaration in the C programming language by default index starting from 0, 0, 1, 2, 3, 4, 5, 6, 7. This is the only twist. In this problem, twist is going to be, right, array index starting from 0. And one more, see this one more. Can you help me? What the partition algorithm will return normally? Partition algorithm normally will return position of the pivot element. Now he is mentioned, what he said? The return value is the number of elements in the left part. Can you say left part, how many elements are there? 4 elements are there, m value 4. Partition algorithm finally return number of elements present on the left side. But normally we will say that partition algorithm will return pivot element position. Same thing indirect way he mentioned. Right? And one more, array index is starting from 0. Please be careful. Next one, it will return left hand side, how many elements are there? It will return that number. Right? This is the only change, remaining all will be normal. And one more, if you see this algorithm, int kth smallest element, see the inside. Int left hand is equal to partition of a comma n. Can you help me now? Partition of a comma n. What it will return? M, that is a 4. Left hand is 4. It will return number of elements on the left side. And one more, can you help me? In this algorithm, I want to find out fifth smallest element, assume. K is equal to 5. I want to find out fifth smallest element. What he will do? Apply partition. He return m is equal to 4. What is the meaning? Left hand side 4 people are there. So left hand contain 4 people. Left hand is 4. Now what I have to do? 4 plus 1, 5. Right? 4 plus 1 is 5. So is 5 is equal to 5 or not? Yes. Indication that you got fifth smallest element. How you got fifth smallest element? Return a of 4. Return a of 4. See this one. This. Fifth smallest element k. Not return a of 5, return a of 4. Because in the fourth place, fifth smallest element is there, because array index is starting from 0. This is the only twist in this problem. Other than this, nothing there. So you complete remaining part, nothing is there. Small adjustments you have to take care. The answer of this problem is going to be, what is the answer? Option A. I done. Please verify yourself. Array index is starting from 0. Remaining all will be normal. Option A will be the answer for this. For this problem, answer is going to be, question number 15, answer is going to be option A. Please verify yourself. Next one, question number 16. See the question number 16 now. Question number 16, if you observe, consider an array consisting of the following elements in unsorted order. Consider an array consisting of the following elements in unsorted order. 60 as first element. Right? One array is given. There is one array which is the unsorted array where 60 as the first element. 60, 80, 15, 95, 7, 12, 35, 90, 55. There is one array which is unsorted and one more, 60 as the starting element. Next one, quicksort partition algorithm is applied by choosing the first element as pivot. By taking this as the pivot, partition algorithm is applied. Right, that's okay. How many total number of arrangements of array integers is possible, preserving the effect of the first pass of the partition algorithm? Can you help me apply partition algorithm? If you apply the partition algorithm, what will happen? 60 will go to correct place. Less than 60, if you apply the partition algorithm first time, 60 will go to correct place, less than 60 one side, more than 60 other side. What are the less than 60? Less than 60, who are the less than 60? Right, write all of them. 15, 7, 12, 35, 55. Less than 60 if you observe, 15, 7, 12, 35, 55. Who is the more than 60? 80, 95, 90. So, if you apply partition algorithm by taking 60 as the pivot, 60 will go to correct place, less than 60 one side, more than 60 other side. See, this order may change. Right, one book to another book, partition algorithm, see, one book to another book, partition algorithm way of writing is different. But one thing, pivot element will go to correct place. Less than pivot, one side, more than pivot, other side. This order may change, this order may change. How many ways you can arrange this? What is the answer? I think these 5 people, 5 factorial ways I can arrange. E will be fixed. Can you say these 3 people, how many? 3 factorial ways you can fix. M ways, N ways, both can be done. M into N ways. What is the answer? 5 factorial into 3 factorial. Preserving the first pass of the partition algorithm. What is the answer? If you apply the first pass of the partition algorithm, pivot element will go to correct place. Less than pivot, all will go one side. Their order may change. More than pivot, all will go right side. Their order may change. So 5 factorial into 3 factorial. What is the 5 factorial? Right? I think 120. What is 3 factorial? 6 will be there, which is finally 720. The answer for the question number 16 is going to be 720. Nothing there. He is simply saying that after partition algorithm is over, right, the output whatever is came, how many ways you can arrange? 720 ways I can arrange. Less than 60 one side, more than 60 other side. These you can arrange whatever way you want, because right, different books are having different partition algorithms. Right? So, in all the partition algorithm, one point is common. What is that? Pivot will go to correct place. Less than pivot one side, more than pivot other side. This one algorithm to algorithm, it is keep on changing. Algorithm to algorithm, this order also keep on changing. So, you can arrange this one 5 factorial. You can arrange this one 3 factorial. Right? Totally 720 ways you can arrange at the end of the first pass of the partition algorithm. For the question number 16, answer is going to be 720. Now go to the next one. Question number 17. Question number 17. What is the answer? Question number 17 answer is going to be, right, A4. Right? Some people are asking, sir, how? Because of he is asking minimum. Sorting algorithm name also not mentioned. Minimum number of comparisons required. When you say minimum, so which sorting algorithm will give minimum? I think insertion sort algorithm. To sort 5 people, insertion sort algorithm will take only 4 comparison. Let me write now. Using insertion sort. Question number 17 answer is A, which is 4. Using insertion sort. Some people are asking, sir, how can you say insertion sort? He is saying minimum. Sorting algorithm name is not mentioned. If sorting algorithm name is mentioned, only that algorithm, best case I will take. Because of no algorithm is mentioned, I have the freedom of selecting any sorting algorithm. Because of minimum sorting required, okay, insertion sort. Right? If you mention sorting algorithm, only that algorithm I will take. E not mentioned means I have the freedom. And one more thing, you have the freedom means you can select whatever you want. But I want minimum sorting algorithm which will take minimum comparison. I think insertion sort. Question number 17, answer is going to be A. 4 is the answer using insertion sort. Right. Let's see the question number 18. This is the question number 18. In the question number 18, one array is given. That array name is X. In the question number 18, one array is given. That array name is X. That is okay. And one more thing he said. One more thing what he said is, in this array, a element is said to be a leader. A element is said to be a leader if it is greater than all elements present on the right hand side. So, 90 is a leader or not, how to check? Go right hand side of that, comparing with all of them. If it is greater, then it is a leader. Now, can you help me? Is 90 is a leader or not? See, 90 right hand side you go. See this one, scan all. right? I think no right is 1. I think if you observe clearly, comparing with all of them is greater. So 90 is a leader. Can you help me now? 25 is a leader or not? What is the answer? Right hand side, if you observe clearly, right? If comparing with all the people on the right hand side, if it is greater, then only is leader. There is not a leader. Why? There are some people who are greater than him on the right hand side. He is not a leader. So that is the leader definition. A element is said to be a leader in this array if and only if right hand side of that whoever there comparing with all of them, if that element is greater, then it is a leader. I think leader definition also okay. Now he is asking, right, in this array to find out all leaders, best algorithm time complexity how much? In this array to find out all leaders, best algorithm time complexity how much? Right? Let's see one algorithm. He is asking best algorithm. Right? Let me say one algorithm first. One algorithm is going to be start from left side. This person will ask. Start from left side. This person will ask all the people on the right hand side. Saying that comparing all of you, am I greater or not? Right? He will ask all the people worst case. Right? Suppose all the people are saying that, right? You are greater. This person is asking everyone saying you are greater. So he asked everyone said, then he is a leader. So worst case how much time? He will ask all the people n time. Again he will also ask all the people n time. So to find out all leaders everywhere n, like that n time n square. One algorithm time complexity n square. It is the one algorithm. Right? If you start from left hand side, one algorithm possible, that algorithm time complexity n square, worst case. Some people are asking, sir, why are you finding worst case? Why don't you find out best case? But what is given? If you see the problem, he is asking the best algorithm to find out all leaders in an array. Try to remember, he is asking best algorithm, not best case. If you write the best algorithm, to that best algorithm, what will be the worst case? By default, worst case only. If you don't mention anything, normally we will find out worst case only. What is the reason? If at all your algorithm is the best algorithm, to that algorithm, what will be the worst case? Then I can say your algorithm is best. See, worst case also, your algorithm is giving less value, then that is the best algorithm. So normally people will find out worst case only if they don't ask anything. He is not asking best case, he is asking best algorithm time complexity how much. Best algorithm, if at all he is asked best algorithm best case, then go for best case. Best algorithm worst case, then go to the worst case. If he mentioned only best algorithm, by default worst case only. Right? Fine. Anyhow, so if you start from left side, what the worst case will come? N square. Why? Every element will take n time, like that n times n square. Start from left side, that is the story. Start from right side, see the answer. Start from right side. I am starting from right side. Listen everyone, I am starting from right hand side. If you go right hand side, right, last element if you observe, after him no one there. If at all after him no one, without any comparison, he is the leader. Last element is always leader. That is fine. So I went to the last element, after right hand side no one there, no need to compare also. So 55 is a leader. But one thing, as of now this part is completed. In that part, what is the maximum? 55. In that part maximum is 55. Please be careful. 55 is a leader, I stored already. Next one, as of now whatever is over right hand side, maximum is 55. Please be careful. Right? Now come to the next, 40. I want to know 40 is a leader or not. If you want to know 40 is a leader or not, no need to ask all the people. This maximum ask. Right? Right? This 40 is asking this maximum. Until now right hand side, what is the maximum? What he said? 55. 40 is asking this maximum. Right hand side, as of now whatever is there, in that what is the maximum? He said 55. Okay, 40 got to know. Right hand side one person is there more than me, so he is not a leader. Because of he is not a leader, no need to print him, but no need to change also. If more come, change. More not coming, don't change. So finally what is the answer? In this area, right hand side maximum is 55. Right? Whatever is over until now, right hand side maximum is 55. As of now, only 55 is leader. Those people who are having little bit doubt also, let's see the next story. So I am thinking, I am asking this person, I am asking 4, are you leader or not? What the 4 will do is, actually what 4 have to do, it has to ask everyone, but it don't ask. Right? It will come to the maximum, it will ask. Right? 4 is asking maximum. Right hand side as of now, what is the maximum? 55. So to him right hand side maximum available as of now is 55. Then 4 got to know that I am not a leader. So because of he is not a leader, don't print, and one more. Because of he is not more also, don't update. Whenever more coming, I will update. As of now, right hand side more is 55 only. So no need to update. Again, 31 I am asking, are you leader? He will ask. Right hand side whatever is there as of now. In that maximum 55. So there is one person more than 31. So 31 cannot be a leader. No need to print. Because of he is not more also, no need to update. Next again, right, 90. 90 is a leader or not, I want to ask. So what the 90 will say? He will ask. Maximum. Right hand side as of now whatever is there, in that maximum 55. Comparing that, this 90 is bigger. Indication that. See, comparing maximum, right hand side maximum is 55. Comparing this is maximum. What is the indication? Comparing all the people on the right hand side is more. So he is a leader because of more. Update it. Next, similar way. 15 is asking 90. 15 is asking this maximum person. Right hand side whoever is available as of now. Among all of them, who is the maximum? 90. Comparing 90 and 15, 90 bigger. Indication that there is a someone on the right hand side who is more than him. He is not a leader. So, he is not a leader, no need to print, but no need to update also. Now, again 75, ask same. There is one person on the right hand side more than him. He is not a leader, no need to update, no need to print. Next one, 25. Right? So, there is one person on the right hand side more than him. He is not a leader, no need to update also. So, I think only two leaders. Who are those? 55 and 90. Can you say how much time? I think every time one comparison is going on. One comparison, one comparison. How one comparison? Just compare with the max. So, this person, no need to compare with all. Right hand side, whoever is maximum is there. With that, he will compare. So, whenever 90 is coming, right hand side maximum is 55. With that, he will compare. He got to know right hand side maximum as of now is 55. 90 is more than that, means he is leader. Because of he is a leader, update also. Right? Like this. I think one scan I done. One scan. Everywhere constant time, constant time, constant time, like the n time. So, this algorithm will take order of n time. If you do from left hand side, everywhere n, because he will ask all. He will also ask all. This algorithm will take n square time. This is also one of the algorithm. This is also one more algorithm. Best algorithm is this. Can you help in a best algorithm, worst case time, order of n. Best algorithm, this is the best algorithm, worst case time is order of n. Best case also same, because for every element constant. Like that n time n. So, listen, can you help in what the answer for this problem? If we scan from right to left, then you will get the time complex to order of n, which is the linear time. Can you help in what the option be? Solves in linear time using right to left pass. Right to left pass. Right? Linear time means order of n time. For the question number 18, answer is going to be second option, B. Question number 18, answer is going to be second option. This is the question number 18, please be careful. 18, answer is going to be second option, time complex to order of n, right to left you have to come. Please be careful. Next one, go to the next one now. Question number 19. Question number 19. The number of comparisons required to find maximum and minimum in the given array of n elements using divide and conquer. What is the answer? This is there directly in your notes. What is the answer? Question number 19. D is the answer. What is that one? 3n by 2 minus 2. Right? Floor or ceiling, whatever it is. Question number 19, answer is going to be D. Go to the question number 20. Question number 20. What is the answer? An unsorted array contains n distinct element. The number of comparisons to find out an element which is neither minimum nor maximum. What is the answer? You know, this is there in your notes also, option D. Right? Option D. What is that one? Order of 1. Question 20. D is the answer, order of 1. Question number 21. Question number 21. It is there in your notes also. Let's check what is the question number 21. Assume an array A 1 to n has n elements, and every element of an array is positive, and all elements are less than or equal to n. Array contain indexes 1 to n, and every element in that array is, right, all are positive, and right, less than or equal to n. Maximum n, every element if you observe, no negative number also there, right? No negative number also, all are positive numbers, right? And equal to n, more than n, no one there. Less than 0 also, no one is there. So, what indirectly, directly what I want to say is, there is one array which contain indexes 1 to n, where values are 0 to n. Where values are 0 to n, because negative also not there, more than n also not there. So, that is the given array. There is one array which contain n elements, indexes are 1 to n, values are 0 to n. Okay, until now it's okay. Next line. An element is said to be a majority element if it is occurred more than n by 2 positions of the array. So in this array, an element is said to be a majority element if it is appear more than n by 2 positions of the array. This problem you know very well. Next one. What is the time complexity to check whether the majority element exists or not in the given array? And one more thing what I want to say, this is the sorted array or unsorted array? Nowhere is mentioned sorted. So it is unsorted array. And one more, unsorted array is given. Majority element definition also you know. What is the majority element definition? If it is appear more than n by 2 times in the given array, that is a majority element. Now is asking what is the time complexity to check whether the majority element exists or not. What is the answer? So if you want to find out the majority element, what is the first thing you have to do is first to sort. First to sort. Second step, after sorting, if at all majority element exists, he should be middle person. First to sort, if at all majority person is existing, right? After sorting, he should be middle person. But one thing, majority element is existing or not, you don't know. If at all there, find it. If not there, return -1. See this one, I am repeating once again. What is the time complexity to check whether the majority element exists or not? First to sort, if at all majority element exists, he should be middle person. But middle person doesn't mean that majority element. If at all there, middle. Right? How you know that he is there or not? After sorting, go to middle person. If at all there, he will be the answer. Take him. Afterwards, after taking, you have to verify. How to verify? Just see this one. After sorting, is a middle person. How to verify? Assume that. Middle person is 20. Assume. First to sort, then go to middle place. If at all majority element is there, that should be middle person. Go to middle person, I think middle person is 20. Then what you do is, if at all there, he will be the answer. But no confirmation that he is there or not. Then what will you do? If at all there 20 only, but not confirmed is there or not. So simple thing what will you do is, because of answer is confirmed already, if at all there, that is the 20, what you do is, using binary search, find the first 20. Using binary search, find out the last 20. Right? Assume that first 20 is there in ith place. Right? Assume that last 20 is there in the jth place. Now what will you do is, find out I to j how many elements are there. J minus I plus 1. These many elements are there. Right? So if at all majority element exists, he will be middle person. But not confirmed. Majority element exists or not confirmed. If at all there is. So 20 is the majority element if at all exists, but not confirm. How to confirm? Is repeating n by 2 times or not verify. How to do that? Using binary search, find the first 20. Using binary search, find the last 20. First 20 is there in I place, last 20 is there in the j place. I to j how many 20? I to j how many elements are there? Find out. J minus I plus 1. If this value is greater than n by 2. Then it is a majority element. Otherwise, not majority. Can you help me now? Sorting, afterward 2 times you have to apply binary search. Why 2 times? First 20 finding, last 20 finding. 2 log n. Next one, sorting will take how much time? Everyone know. Sorting normally will take n log n time. But here sorting will take n time only because the range given. What is the range given? All elements are in the range of 0 to n. All elements are in the range of 0 to n. Counting sort will take n time. Because of range given, apply counting sort. Counting sort apply. Counting sort will take, range is 0 to n means n time. If range is 0 to n square, n square. If range is 0 to n cube, n cube. If range is 0 to log n, right, n time only. What is the reason? N elements are there. If range is less, then also n time. If range more time. Range is 0 to n time. Range is 0 to n square. Range is 0 to n cube. If range is 0 to log n, then n only, because n elements are there. So because of range is there, 0 to n, if you apply counting sort, n time. Some people are asking, sir, how you know counting sort you have to apply? Range given, right? Range given, let me write range. Range given, so apply counting sort, n time. So sorting will take n time. Verification will take log n time, overall n time. To this problem, answer is n. It is there in your notes also. For the question number 21, answer is B. 21, answer is B. Please be careful, it is a nice problem. Why 2 log n? 2 times binary search for verification. First, some people are asking, why are you verifying? I don't know majority element is exist or not. If at all there, we have to find out. See, if you want, you can read the problem. What is the time complexity to check whether the majority element exists or not? Because it is not confirmed, you have to verify. Verification 2 log n. How you are verifying? First middle element find out, last middle element find out. If at all majority E should be, but no confirmation. How you confirm? E should be there n by 2 times. How to count? Find the first 20, find the last 20. So first 20 there in ith place, last 20 there in the jth place, j minus I plus 1. If it is more than n by 2, then it is a majority element. If it is less than n by 2, it is not a majority element. So 2 times the binary is 2 log n, sorting will take order of n, finally order of n. Question number 21, answer is B. Next one, go to the question number 22. Question number 22, what is the answer? He is asking binary search possible on which data structure? On every data structure binary search is possible. Binary search means directly go to mid element. In array directly you can go to mid element because in the array random access possible. In stack also I can go to mid, but going mid itself is complex story. Because stack always you can access topmost element only. If you want to go to mid element in the stack, right, half of the time you have to pop, that itself will take n by 2 time. Right? Q always will give first element, but I want middle element. From the Q you have to delete half elements. In the linked list random access is not possible, but still you can go to middle element. You have to cross 1 by 1, 1 by 1, 1 by 1. So question number 22, binary search possible everywhere, but efficient one is array because random access possible. Directly I can go there. Some people are asking, sir, what is the meaning of binary search efficiently? What is the meaning? On array, if you apply binary search, time complexity log n. If you apply on some other data structure, time complexity may be n time. Some people are asking, sir, why n time? If you want to go to middle in stack, half time you have to pop n by 2. N by 2 pop you have to do, which will take n by 2 time, which is nothing but order of n. Right? In the Q also, if you want to go to middle from the Q, from the first onwards, half of the element you have to delete. That is also n by 2. In the linked list also, if you want to go to middle, what is the answer? From the first onwards, half element you have to skip. In the case of array, random access possible, directly you can go constant time. So in all the four data structure, every data structure you can apply binary search. But efficient one is array because every one of binary search means what? Time complexity log n, array only log n, remaining data structure. Binary search possible, but it will take more time. So for the question number 22, read it. Binary search can be carried out on a set of data items stored in, what is the answer? All. Best one is array. So you can select A as the answer. Not for namesake, right? Not for namesake, efficient answer is going to be A. For the question number 22, all are correct only for namesake, but efficient one is A. Right? Question number 22, answer is A. If anyone say, question number 22, if anyone say, on stack binary search not possible, what is the meaning of their intention? Possible, but it is taking lot of time. If lot of time is taking, what is the purpose of binary search? Linear search already n, binary search also n. What is the use of binary search? Binary search possible means it should take log n time. Only for namesake possible, but actually they are taking n time. What is the use of it? So for the question number 22, what is the answer? A. Right? Meaningfully binary search possible only in array, in other places only for namesake possible. 22 answer is A. Go to the next one. See the question number 23. Question number 23, what they are saying is, two sorted arrays are given A1 and A2, right? If you do union of that, so you will get the one union sorted array. In that union sorted array, to find out median, how much time? I am repeating once again. The question what they are saying is, given two sorted arrays, right? For that, if you find out union sorted array, in that to find out the median element, how much time it will take? That is the thing what they are asking. Now can you help me one small line now? What is the meaning of median first of all? Median is nothing but in the sorted array, middle person is known as median. In the sorted array, middle person is known as, right, median. Please be careful. Now can you help me now? A1 is sorted array. What is the median? A1 is sorted array. What is the median? What is the median? Middle person. A2 also sorted array. What is the middle person? Can you help me now? A1 contain how many elements? 10 elements. Now A2 contain how many elements? I think 11 elements. A1 contain 10 elements, A2 contain 11 elements. Now can you help me now? So in the first array which is sorted, What is the median? Right? Median is nothing but sorted array middle person. You only said 10 people are there. What is the middle? Everyone know. Right? Even number, exact middle is not possible. Odd number, exact middle is possible. How? Every odd number can be written as 2 into x plus 1. That plus 1 is middle. But in the case of even number, every even number can be written as 2 into x. I think 2 halves you can divide, middle person not there. Can you help me now? For the first half, first, see everyone now, first sorted array, middle person. Because of exact middle is not possible. So what is the answer? 10 people, 10 by 2, 5. See this one. I think these two are middle people. In the sorted array, middle person is known as median. Number of elements are even. So exact middle is not possible. So two middle people are there. Median is nothing but these two people, sum you do. 40 plus 50 by 2, which is going to be 90 by 2. What is the answer? 45. So for the first array, median is 45. Normally median means sorted array middle person. Because of here number of elements are even, exact middle is not possible. So what will you do? Just add both of them, divide by 2, 45, which is going to be median. For the first array, median, what is the answer? 45. How much time? Constant. Why? It is already sorted, middle person, right? Just to take the two numbers, because of exact middle is not possible. So that is going to be median. If you see the second array, 11 elements are there. 11 can be written as 2 into 5, 10 plus 1. What is the meaning? 2 into 5. 5 left, 5 right. I think this is the median. In the sorted array, middle person, I think exact middle is possible. This is the median in the second array. In the first array, median is going to be 45. In the second array, median is going to be 61. Everyone know. And it is an interesting question to ask you. Can you see in the sorted array, to find out median, how much time? Constant. In the sorted array, to find out the median, constant time. In the first one, to find out median, constant. In the second array, to find out median, constant. Why? They both are sorted. Some people are asking, sir, if they are not sorted, then what is the answer? If they are not sorted, if you want to find out median, first to sort, then try to find out median. Sorting will take maybe n log n time, n log n plus constant, finally n log n. Because of two things are given sorted, finding median directly constant time, because directly middle you can take. Now let me ask you one small one. If array not sorted, to find out median, how much time? One idea is going to be sort and take median. Sort and take the middle person. That is the one idea, which will take n log n. One more algorithm is there. To find out the median. Right? That algorithm will take order of n time only. Please be careful. One more algorithm there to find out the median. That will take order of n time only. That is going to be median of 5 algorithm. So last time I want to ask you, in the unsorted array, to find out the median, how much time? Unsorted array, to find out the median, one way, sort and take middle person. One more way, right? Right? There is one nice algorithm to find out the median, which will take order of n time. To find out median in unsorted array, 2 algorithm, sorting, that will take n log n, one more algorithm. Without sorting, directly you can find out median. That is the median of, using median of 5 algorithm, that will take order of n time only. Right? Best algorithm is order of n time. Right? If you want, I will write that also. See this one. If you want, I will write that out. See this one. Sorted array, finding median, how much time? Sorted array, finding median, how much time? Order of 1 time. Sorted array, finding median is order of 1 time, every case. Next one more thing let me write. Unsorted array, to find out finding median, how much time? Unsorted array, finding median, how much time? Try to remember. Best algorithm I am writing, order of n time, every case. Please remember this algorithm. Right? If you want, you can type in the Google also, you will get the nice algorithm. Unsorted array, finding median, how much time? Order of n time. It is a well-known algorithm, median of 5 algorithm, which will take order of n time. Please remember. Because of our problem is not that one. That is the reason I am not covering that. See this one. Sorted array, finding median, constant every case. Unsorted array, finding median. One is sort and find the middle element. That is one way. One more. Without sorting also possible, which will take order of n time every case. Please remember. This note. Right? Let's come to our actual problem. Can you help me now? 2 sorted arrays are given. Two sorted arrays are given. In the union sorted array, to find out median, how much time? That is our actual problem. Right? Before going to that, few things required I said to you. Can help in the first half to find out the median, how much time? Because of sorted, directly take middle. If middle exactly not possible, just add both of them, take the average, which will goes to median. In the second array, if you see 11 elements, exact middle is possible. So this is median. For the first half, listen everyone now, for the first array, median is 45. For the second one, median is going to be 61. Can you help Union sorted array. Careful listen. Union sorted array, what is the middle? Union sorted array, what is the middle? Which is nothing but union sorted array, what is the median? We will see now. We will see within few minutes. And one more. If you see the problem, right? Two arrays are there. Each contain n elements. What is the meaning? First half contain n element. Second also contain n element. Let me write one more. Both contain n elements. See this one? It is 11. It is the 110. First also contain n elements. Second also contain n elements. Union sorted array middle. See this one. Union sorted array middle, which is nothing but union sorted array median, which is nothing but middle element only. So how to find out? See this one. The two sorted arrays are there. Union sorted array middle person I want, which is nothing but union sorted array median I want. How to do that? One way is going to be just apply merge algorithm. One way. See this one. One algorithm. Right? One algorithm is going to be, right? Let me write this one. One algorithm is going to be first to merge. Merge both of them. After merging is over, right? Just to take the middle person. After merging is over, take middle. This is the one way. Can you help in first one contain how many elements? N. Second one contain n elements? N. Merging will take how much time? N plus n. What is the answer? 2n. Middle element taking how much time? Constant. So overall is going to be order of n. This is the one algorithm. In the union sorted array, taking the middle person will take order of n time. What is the first idea? What is the one algorithm I mentioned? Merge first. Then take middle one, which will take order of n time. Merge algorithm will take, right? Because of two sorted arrays, merge algorithm will take m plus here m plus n. Here n, so 2n. Middle element you take. If at all exact middle is possible, you take. Otherwise, just right, middle two people you take, do the average, then it is get the median. So one algorithm, it is a very easy algorithm, everyone knows this. One algorithm. To solve this problem, one algorithm I written order of n. Can you help me now? So question number 23, what is asking? How much time it will take to find out middle element of the union sorted array? So what is the answer? Order of n. This answer everyone know. One more algorithm is there, which will take less than n time. One more algorithm there which will take less than n time. Right? I will explain that algorithm. Our goal is algorithm 2. I will explain now. Right? Let me take all the values once again. I will explain second algorithm. See the algorithm 2. It is very, very important. Algorithm 2 I am doing. See this. A1, A2. Both are same size. Let me write. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Right? 100. Here I think 10 elements. Next one. See the next one. 11, 21, 31, 41, 51, 61, 71, 81, 91, 101. Both are 10 elements. Let's see the indexes also. Now you only say, in this is one, union of these two sorted arrays if you find out, right? Afterwards middle element. Can you help me now? Who may be the middle element? Let me find out. Before going to start algorithm 2, unions, right? Can you help me in the first half? If you want, you can go to the 11 elements also. I don't have any problem. See, here 11, here also 11 elements. See this one, it is the 110, it is going to be 111. Now see this one. Yeah, see this one. Algorithm 2, union sorted arrays, right? Union sorted arrays. Median you want to find out. How to do that? First array contain, right, 11 elements. Second array also contain 11 elements. Both are sorted. Can you help me now? In the first array, what is the median? Because of 11 people, what is the median? I think 5 this side, 5 this side. I think 60. In the second one, what is the median? Here also 11 people, 5 and 5, I think 61, right? In the first half, median is 60, right? In the second half, median is going to be 61. Everyone know that. Union sorted array, what is the median? Let me check here. Union sorted array, what is the median? Let me check here. Let me write the values here. Right? Union sorted array I want. Let me write 10, 11, 20, 21, 30, 31, 40, 41. Just check here. 50, 51, 60, 61, 70, 71, 80, 81. Next one. 90, 91, 100, 101. Next one. 110, 111. This is the union sorted array. This is the union sorted. How many elements are there? Let me write that also. How many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Total I think 11 plus 11, 22 elements. If 22 elements are there, you only say what is the median. 22 elements are there, what is the median? Because of it they exactly, right? I think it is an even number. Exact middle is not possible. So what is the answer now? 22 means what? 11, 11, right? 11. See this one? I think 11, 12. This side is 10, this side is 10, 20, I think this one. Can you say what is the average of this? 60 plus 61 by 2. What is the answer? 121 by 2, which will goes to 60.5. Right? So, union of these two sorted arrays. Right? This is the answer. In that middle person, two middles will come, 60, 61. What is the union sorted array? Union sorted array middle person, I think, right? So, median is going to be 60.5. This will be the answer, right? Using second algorithm, can we get this or not? Let's check. To this problem, answer is going to be, what is the median? 60.5. Can I get the same thing or not? I will try. Right? See this one. Algorithm 2 I am trying. One way of getting the, see this one. One way of getting the, one way of solving this problem is going to be, just to do whatever, just to do merge algorithm, time complexity is going to be 2n, which is order of n. One more algorithm is there. That algorithm I am explaining. Before going to start algorithm, right? I want to explain what will be the answer. I already done. What is the answer? Answer is going to be 60.5. Answer is going to be 60.5. How to get it? I will explain. Can you help me now? A1 contain how many elements? 11. A2 contain how many elements? 11. Both are equal size, because in the problem is mentioned, right? There are two sorted arrays, each of size n. You want to find out union sorted arrays, right? Median you want to find out. How? One algorithm I explained, the one more algorithm, right? To this problem, answer also I explained, 60.5. How to do that? I will give the answer. Can you help an algorithm one time complexity? I already written. What is the answer? Order of n, using merge algorithm. Algorithm 2 time complexity, right? So what is the answer? I will explain. Very simple. Careful from now onwards. It is very simple. Can you help me now? Can you help me now? See the algorithm now. See the algorithm. This algorithm, if you observe, what will you do is, this is the answer. See the algorithm. So first step is going to be, first step in this algorithm is going to be, find the median of first array, second array. Find median of first array, second array. First to find the median. Median of first array, second array, find out. Can you help me now? I am repeating once again now. Algorithm 2 I am explaining. First step is going to be median of first array, find out median of second array, because both are sorted. Find the first median of the first array, second array. Can you help me now? First array median 11 people. What is the answer? Sixth person 60. Right? Second array also find out the median. What is the answer? 61. Find the median of first array, second array. Right? I find out first array median is going to be 60, second array median is going to be 61. Right? Please be careful. Now can you help me one small line now? After doing this one, second step is going to be this one. Second step is going to be compare both the medians. Compare both medians. First to find the median, next one. Compare both the medians. Can you help me now? If you compare both the median, assume that it is the median 1. Right? I am repeating once again. Assume that it is the median 1. It is the median 1. Compare both the medians. Yes. Assume that it is the median 1. It is the median 2. Compare both of them. Right? If you compare both of them, can you help me now? Comparing median 1 and median 2, which is greater? First to find the medians of each. Next, first median is assumed that M1, second median is assumed that M2. Can you compare the M1 and M2? Can you help me now? If you compare the M1 and M2, which is greater? Compare both medians, yes, right? Find who is greater, right? Compare both the medians, that is fine. Now see the first step. See the first step. After comparing both the medians, see the first step. 1. If M1 is greater, that is the one step. Second one, 2. If M2 is greater, just compare both of them, then ask one question. Easy, right? If M1 is greater, one story there. Right? If M2 is greater, one story there. Can you help me one small line now? M1 is greater. Comparing M1 and M2, assume that M1 is greater. M1 is greater. Can you help me now? If M1 is greater, comparing M1 and M2, here who is greater in this problem? Please check. Comparing M1 and M2, here who is greater? Right? I think M2 is greater. You only say if M2 is greater, comparing M1, if M2 is greater, definitely median should be, what is the answer? In the 2 n people, see, only n people is the median. Only n people is the median. It's fine. Now, right, when you do the union, total becomes 2 n people. Right? Can you help me now? M1 is 60, M2 is 61. Comparing M1 and M2, who is bigger? M2 is bigger. M2 is bigger means where can be union median? Comparing M1 and M2, M2 is bigger means where can be, right, union median. What is the answer? I think because of this person is smaller, right, union median may be there. I think in the right half of this, R, because of these are great, this is the greater, R left half of this. Comparing M1 and M2, if M2 is bigger, what is the meaning? I think M1 person is smaller. Because of in the union sorted array, you want median. What is the meaning? I think because of these are smaller, I think median may be there in the union sorted array. Maybe in this area. In this area cannot be because these are smaller. Right? In the 2 n people, see this one. Only in the n people, these are smaller. Only in n people, these are smaller. But in the 2 n people, I want the middle person. 2 n people, middle person I want. So definitely, M1 and M2 is bigger means these are smaller. Definitely, union sorted array, middle person should be there. On the right side of this, right half of this, or left half of this. So let me write now. Compare both the medians, right? If M1 is greater, one story. M2 is greater. Can you help me? If M2 is greater, then what is the answer? Then, if M2 is greater, then you have to do this story. See this one. Then, find median. Carefully listen. Then find median. Find median. What is the answer? Then find median. See this one. First array from where to where? Find median, right? In first array from where to where? M1 and M2 is greater, M2 greater. First array, what is the answer? M1 to, right, last element. Second array, what is the answer? Second array, what will happen is first to M2. So this is the answer. Compare both the medians. If M2 is greater, indication that, right, then definitely in the union array, median should be there. In the first array, second half, or in the second array, first half. Supposition that M1 and M2 is bigger. What is the meaning? M1 and M2, I am repeating once again. Comparing M1 and M2, M1 is bigger. Means M2 people are smaller. Then find median. In, what is the answer? First array, second array, where to where? In the first array, because of M1 is bigger, right? So in the second array, from where to where? Because the second people are smaller. Then what is the answer? I think M2 to last. What about this one? First to M1. So this is the story what you have to continue. Algorithm is very simple. Compare both the median every time. See this one. This is the algorithm. Compare. First of all, this algorithm is very simple. First step, find both the medians. Yes. Compare both of them. Yes. If you compare both of them, if m2 is greater, if m2 is greater means m1 is smaller one, indication that median should be there, right? Right, median should be there first half, right? First array second half, or right, first array second half, or second array first half. Suppose that m1 is greater means m2 people are smaller, that indication that second array second half or first array first half, right? Continue second step, continue above steps, continue above steps until both contain two elements each. Continue above steps until both contain two elements each. Some people are asking, sir, what is the meaning of this? I will execute algorithm, don't worry, right? I written only for namesake this algorithm, I will execute now. Can you help me now? Find both the medians. Yes, I find out. Can you help me? If you find both the medians, can you say first half median 60, second half median 61. Compare m1 and m2. Who is bigger? m2 is bigger. m2 is bigger means now where can be median? What is the answer? Right? First array second half or second array first half, because of this person is bigger. Right? This. Now let me write now. After doing the one time, this is the story. Now what is the answer? Previously a1 contain n elements, a2 also contain n element. Now after applying this story, what is the answer? a1 and a2 becomes half. Can you help me now? Right? So from in the a1 what is the half? In the a2 what is the half? Let's check. In the a1 which part you will check? Left part or right part? Right part. So what is the answer? 60, 70, 80, 90, 100, 110. Can you say what about a2? 11, 21, 31, 41, 51, 61. This is the answer. Just this will be continued until both the groups contain two elements each. Let's start again. Same thing I am starting now. Those people who disturbed little bit also, this algorithm I have to implement this algorithm. Let me start once again. Can you help me now? In the a1 find the median. In the a1 find the median. So what is the answer now? How many people here? a1 find the median. Can you say how many people here? I think how many? 6 people. Median is I think sum of these two by 2. What is the answer? 80 plus 90 by 2. How much? 80 plus 90 by 2. What is the answer? 80 plus 90, which is going to be 170 by 2. What is the answer? 170 by 2 means how much? 135. 80 plus 90, I think 160, 170 by 2, which will goes to 85, 160, 170. That is okay. Next one. This is also same story. Find out the median. 31 plus 41. What is the answer? 72 by 2. What is 36? So first find the median. Yes, I find out. Can you help me now? For the first one, what is the median? 85. For the second one, what is the median? 36. Now do the same story. What is the answer? Compare both the medians. Comparing first median and second median. Which one is bigger? First median. Then what is the answer? Then your answer should be what is the answer? Because the first median is bigger, your answer should be, where should be? I think second half right side or first half left side, including those. Now let's continue. What is the answer? Whatever answer you got, let me write. So a1, a2. Can you help me? What is the a1? 60, 70, 80, 90. What is the a2? 31, 41, 51, 61. Again same story. Continue this one until two elements will come. A1 also contain two elements, A2 also contain two elements. Continue that. I am continuing now. Can you help me now? Continue. Find the mid element. Right? I think mid element again here even number. So 70 plus 80 by 2. What is the answer? 70 plus 80. What is the answer? 140, 150. What is the answer? 150 by 2. Which will goes to how much? 75. This also find out median. What is the answer? 41 plus 51, which will goes to 92 by 2. What is the answer? 92, I think 46. Right? Fine. So now check once again. Median, both the medians compare. If you compare both the median, one is 75, another one is 46. Which is bigger? First one is bigger. Then what the answer? Comparing M1 and M2, M2 is big, M1 is bigger. What the answer? If M1 is bigger means, M1 is bigger means, right? I think median should be there. Which side? Because of M1 is bigger. M2 right side, M1 left side, including those, right? Again start. So what the answer now? A1 and A2. Can you help me know what is the A1? 60, 70, 80. What is the A2? 41, 51, 61. Again continue. Find the median, 70. Find the median, 51. Comparing both of them, who is bigger? I think A1 is bigger. Then answer should be, what is the answer? A2 right side, A1 left side. So let me write. So what is the answer now? 60, 70. 60, 70 here. This is 51, 61. Whenever A1 contain 2 elements, A2 contain 2 elements, median is this one. Until two elements continue, now median is finally this one. Median is equal to, write this answer. Median is equal to, see everyone now, median is equal to, see this one. In the A1 first element, but otherwise you can do directly also, meaning is same. Right? So median is equal to, because of only 4 elements are there, sort them. What is the answer? 60, 70. Median is equal to, after getting two elements, median is equal to, because of only 4 elements are there, sort them. What is the answer? 51, 60, 61, 70. Right? Two elements are there, totally 4 elements, sort them. After sorting, right? Middle people take 60 plus 61 by 2. What is the answer? 121 by 2. What is the answer? 60.5. 60.5, like that. Until two elements there continue. Finally median is equal to, because of two totally 4 elements. Just what will you do? Sort one time. I think 4 element sorting will take constant time. Take middle person. Right? Middle person is going to be, right? I think because of 2 middles are there. Just to do the, right, average of both of them, 60.5. To this problem answer, median of these two sorted arrays is going to be 60.5. I think some people are asking, sir, what is the guarantee that it is the correct answer? That is the reason I already done. See this? That is the reason I already done. In the union sorted array, what is the median? What is the median? 60.5. 60 point. This is I done manually. Both the sorted arrays, I done the merging. After merging is there, middle people, these 2 people, right? Just to do average, you got. Right? Same thing can be done efficiently by one more algorithm. What is the algorithm? Right? What is the algorithm? First step, medians of both the arrays find out. Next, compare both the medians. If M1 is greater, right, do something. If M2 is greater, do something. Some people are asking, so what is the meaning of do something, right? Just nothing there. If M1 is greater, both the arrays make half of. First one also make half, second one also make half, one half only you go. Some people are asking me, if the M1 is greater, which side you are going? I written here, right? If M1 is greater, then median should be there. First array where comparing M1 and M2, which one is bigger? M1 is greater. Comparing M1 and M2, if M1 is greater, then your median should be there. First array, see this one, because of is greater, no need to go right side of this. M1 is greater, no need to go right side of this, right? So first array, first half, second array, second half. Because of M1 is greater. Suppose that M2 is greater, M2 people are greater people. Then in the first array, second half, right? In the second array, first half. Right? I am writing. So if anyone having small doubt also, I am writing here. M2 is greater means I think second array contain greater people. Then your median should be there. What is the answer? First array, second half. Because the first array contains smaller people. Right? Already left smaller. Then go further. First array second half and second array first half. Second array first half. It is reverse. M1 is greater. What is the meaning? I think M1 people are greater. So I think M2 is smaller. Then what is the answer now? First array, first half, second array, second half. Second array, second half, first array, first half. Right? Like this is the algorithm. First find medians, compare both of them. If m1 is greater, because of m1 people are greater, so what is the answer? M1 first half only, but m2 second half. If m2 is greater, m2 first half only, but m1 is second half. Right? Continue the same story until, see this one, continue above both the steps. This one, first step, second step. Continue above steps until both contain 2 elements each. So I done that. I done. See the problem? See this one? I compare both the medians. If I compare both the medians, who is greater here? M2 is greater. If M2 is greater, then what will you do is, right? So second half as it is. See this one, second half, first part. Right? First half, second part. M2 greater, whoever is greater, that one first half. Whoever smaller, that one second half. Again here also find out median. If you find out the median here 85, if you find the median here 36, what is the meaning? M1 and M2. Who is bigger? M1 is bigger. Whoever is bigger, that one first half. Whoever is smaller, that one second half. I done this. Again find out median, it is 75. It is going to be 46. Who is bigger? M1 is bigger. Whoever is bigger, that first part. Whoever is smaller, that second part. Again now, it is 70 at the 51. Whoever is bigger, that first part. Whoever is smaller, that second part. Continue. Until 2 elements are there. Right? I think here also 2, here also 2. Whenever 2 elements each came, then what will you do? Right? Just sort them. If only 2 plus 2 means 4 elements. 4 element sorting will take constant time. Right? Afterwards, take middle person. Middle only one there, well and good. Middle one is not there. Right? Just to take the addition of those two, just find the average, that is going to be median. Now one more interesting thing. When you see this algorithm, always you are dividing by 2, by 2, by 2, by 2. If you do always by 2, by 2, by 2, what is the answer? Log n, binary search. The time complexity of this algorithm, second algorithm, order of log n. Question number 24. Question number 24. Which one of the following statement is true? Question number 24. Which one of the following statement is true? 1. As the number of entries in hash table increases, the number of collisions will increase. Entries means keys. Right? As the number of entries in the hash table increases, number of collisions will increase. Number of entries increase means what? I think keys are increasing. If you insert more keys, more collisions will come. Right? It is not hash table slots. As the number of entries in a hash table increases, the number of collisions will increase. So he may be confused you by giving the number of entries. Number of entry means number of keys. Number of keys in hash table increases. Number of collisions will also increase. Right? One may be true. One may be true. Please be careful. Entries means keys. Next one. What are the 2? First one is true. Assume. Second one. Recursive programs are efficient. No, recursive program normally will take stack space. It is not efficient. 3. What are the 3? The worst case time complex to quicksort is n square. True. 4. Binary search is using linked list is efficient. No. Random access not possible. So what is the answer for this problem? For this problem, answer is going to be 1 is true and 3 is true. 1, 3. So I think D may be the answer. Suppose some people are asking, sir, how 1 is true? Suppose that number of entries in hash table increase. Isn't that entry means slot? Right? In the hash table, number of slots increases, collisions will decrease actually. So that time 1 also falls. If 1 also falls, no option is matching. So that is the reason I am thinking that number of entries means number of keys. With that line, let me write now. Entries means, in the first option, entries means keys. With that meaning, 1 is true, 3 also true. So D is the answer. Question number 24. 1 and 3 is true. Means D is correct. That is question number 24 story. What is the question number 25? Question number 25. Question number 25, right? I think this problem already we done. In the sorted array, find 2 people whose sum is less than 1000. In the sorted array, find 2 people whose sum is less than 1000. Take first 2 elements. That will be the answer. Answer is A. We are already done in the classroom. Order of 1 time. In the given sorted array, see one sorted array. In the sorted array, find two people whose sum is less than 1000, because of it is a sorted array ascending order. First two people if you take, compulsory their sum is less than 1000. First two people sum itself is not less than 1000, no one will give. So first two elements itself will say the story. No loop, nothing required. So constant time every case. Question number 25, answer is A. If you see the question number 26, right, what they are asking, the cube root of a natural number n is defined as the larger natural number m such that m cube is less than or equal to n. The complexity of computing the cube root of n is, where n is represented using binary notation. So indirectly, directly what he is saying is, the purpose of this problem is, one number n is given, to that number n you have to find out cube root. How much time complexity it will take if you write the efficient algorithm. I have some number, I want to find the cube root of that number. Efficient algorithm if you write, what will be the time complexity? But the condition here is where n is represented in the binary format. N is represented using binary format. Now this is the question now. What is the answer? Let me check here. Right, let me check. Can you help me now? What is the cube root of 1000? Cube root of 1000 how much? Cube root of 1000 everyone know 10. 10 into 10 into 10. Right? See this one. By doing I cube, if I get the 1000, I is the cube root. There is some number I. By doing I cube, if I get the 1000, then I is the cube root of 1000. Everyone know. So if the question is like this one. Right? For this algorithm, input is going to be n, output is going to be I. Right? You have to find out I such that I cube is equal to 1000. So, some people are asking me one small line now. Sir, I do I cube, right? So I cube is equal to 1000 not possible. Then what is, supposition that exact cube root is not possible. What will you do? What will you do? Closest answer you have to find out. What is the meaning? So it is something like this one. Listen, something like this one. If I want to find out the right, now see this one. How to find out cube root I will explain. See, this is the answer. Carefully listen. Listen everyone now. I want to find out, isn't that n is equal to 1000? I want to find out cube root of 1000. What is the way? This is the answer. Find I such that I cube is equal to 1000. Find I such that I cube is equal to 1000. Some people are asking how. So very simple, right? Take one for loop and continue the I. Let me ask one small. I is equal to 1 for loop. 1 cube check. 1 cube is less than or equal to 1000. Yes. Right, next one, same way, I is equal to 2 you go. What is the 2 cube is less than or equal to 1000, that is also. Next one, I is equal to 3 find out, right, is 3 cube is equal to less than or equal to 1000, yes, continue like this one, continue, right, just to take one for loop, it is a way of writing the program. Just to take one for loop, each I value do this story. Right, I think every time too, I cube is less than or equal to 1000, for initial I value 1, I cube is equal to less than or equal to 1000, true, I cube is equal to less than or equal to 1000, continue, now see the answer, I is equal to 9, what is the answer, I cube less than or equal to 1000, this is also right. Next one, I is equal to 10, I is equal to 10, same, what is the answer, I cube is less than or equal to 1000 or not, this is also true, next one, I is equal to 11, again check I cube is less than or equal to 1000, no, fail, wherever fail happened, right, largest I which passed, I think this one only, this is the cube root, that is what the definition is saying. See the definition, the cube root of a natural number n is defined as the larger number m such that m cube less than or equal to n. See this one, m cube less than or equal to n, m cube less than or equal to n. Many people are satisfied. Which is satisfied this condition? Last one, this one. The larger m such that m cube is less than or equal to n. I think this is the answer for this. This is the way of finding cube root. Can you help me if anyone asks you, how will you find out cube root? This is the way. What is the time complexity? I value 1 you are trying, I value 2 you are trying, I value 3, every one you are trying, linear search you are doing, right? Time complexity, linear search you can do, right? Answer is order of n. To find out the cube root of n, right? One algorithm is there, just to take for loop, just to do linear search. I value 1, I value 2, I value 3 like that. Linear search, time complexity, order of n, that is a one algorithm. See the one more nice algorithm. See the interesting answer? One more nice algorithm, this is the answer. See this one. I is equal to 1 you do first, I is equal to 1 cube you check, less than or equal to 1000, true, right? Next one, see the next one now. I is equal to 1, it's okay. Now instead of increasing by 1, double it, right? I is equal to 2, you check. 2 cube less than or equal to 1000, that is also true. Go further. Next one, instead of doing plus 1 into 2 you do. What is the answer? I is equal to 4 you do, right? 4 cube less than or equal to 1000, that is also true, right? So instead of doing plus 1, do into 2. What is the answer? I is equal to 8 you do. 8 cube less than or equal to 1000, that is also true, right? Continue further. Instead of doing plus 1, do into 2. What is the answer? I is equal to 16, right? 16 cube is less than or equal to 1000, right? Fail. Indication that this is pass, this is fail, means in between you have to check. In between. Okay, can you say what are the in between? Can you say what are the in between? So first thing is going to go to the closest answer, right? I think you done almost like log n. Always into 2, log n you done. Here in this area again same story will happen, right? So some people are asking, sir, how? Again same story. What is the answer? I think more than 8, less than 16. What is the middle number? 9 plus 15, 24 by 2. What is the answer? 12. Again check. I is equal to 12, right? 12 cube you check. Is 12 cube is less than or equal to 1000? No. Again fail. Again, it means always by 2 you do. So what is the answer? Because of always you are doing by 2, it is a binary search, right? Which will goes to log n time. Some people are asking, sir, every time you are checking n, every time less than or equal to n or not, you are checking. But n is given binary format. If n is given binary format, this is one, it is a binary number. N is given in the form of binary format. N is binary format, right? So you are always taking the integer value. N is given binary format, nothing there. Just convert this binary number into decimal number. Binary to decimal conversion you do, right? Some people are asking, sir, binary to decimal conversion how? Nothing there. Every bit, right? 2 power 0. Next bit, 2 power 1. Just multiply. If you multiply, I think log n bits are there. Everywhere multiplying by small constant and all. Right? This will goes to, what is the answer? One scan you are doing log n time. Log n time for conversion, because of n is given in the binary format, convert into decimal. Conversion will take how much time? Log n time. Next one, this particular one will take one more log n time. Log n plus log n, 2 log n. N is given in the form of binary. Convert binary to decimal, which will take log n time. Next one, this procedure will take one more log n, totally 2 log n, finally log n. So time complexity of this problem is going to be log n, order of log n. Linear search possible, order of n. Binary search also possible, right? Actually 2 log n, 1 log n for this procedure, one more log n for this conversion. Why are you converting? N is given binary format. Binary to decimal conversion, how? Because the binary format contain log n bits, right? To convert all log n bits, one scan required by multiplying by 2 power 0, 2 power 1. Conversion will take log n. Some people are asking, sir, you are not converting one time, you are converting every time. You may say like this one. One time convert, store somewhere, use it. Why you convert again and again? One time you convert, decimal number will come. Use decimal number every time. Right, so like that. So I think right, to find out the actual thing, right? Log n, converting the n binary to decimal, one more log n, totally 2 log n, finally log n. So linear search also possible to find out cube root. Binary search also possible. Instead of doing there, I am checking plus 1 until larger number will come. Instead of plus 1 into 2 you do, which will take log n time, right? Finally, the answer for this problem is going to be order of log n. Order of log n. Now some people are asking, sir, which option then? What is the option A saying? Order of n but not root n. So order of n is there, but better than that is possible. So option A fail. What is the option B? Root n but not log n. No, log n is possible. What is the option C? Log n but not log n. Some people are asking, sir, what is that k? For some constant k greater than 0, you can take k value 1. Some constant k greater than 0, you can take k value 1 also. Right? That is the answer. Answer is going to be C. For question number is one. What is the question number here? Question number 26. These are the keywords finally. Question number 26 is one. Question number 26. You can apply binary search. Answer is order of log n whole power k, where k is constant and k greater than 0. K greater than 0, you can take k value as 1 also, no problem. So like that. Binary search possible. Linear search is only n, binary search is log n. Instead of doing always plus 1, just to do into 2. So that's what I done. Some people are asking, sir, n is given binary format. If n is given binary, convert into decimal. Binary to decimal conversion, which will take log n time. How log n time? One scan, all the bits one time you scan. Some people are asking, sir, every time you have to convert. One time convert, store here. Right? Reuse it again and again. So finally, conversion is log n, and finding the cube root is going to be one more log n, because the binary says totally 2 log n, finally log n. For the question number 26, what is the answer? C. Go to the question number 27. Question number 27. I think some recurrence relations are given, right? Recurrence relations are given, names are given, you have to map. Can you help me now? P, binary search. P, binary search, what is the recurrence relation? You know very well. P, binary search, what is the recurrence relation? Binary search, you will go only one side, right, after a constant time. And one more thing, how the recurrence relation matching is, let me check here. Consider a list of recursive algorithms and a list of recurrence relation as shown below. Each recurrence relation corresponds to exactly one algorithm and use it to derive the time complexity. Binary search recurrence relation, only one side you will go, Tn by 2 plus C. Tn by 2 plus. Is there any option like this one, Tn by 2 plus C? I think it is going to be 4. I think P is going to be 4. Next one, can you go to the Q now? Q, what is the answer? Merge sort. Merge sort, what is the answer? Both the side you have to do 2Tn by 2, right? Merging will take n time, right? Which option it is? I think 3. P4, Q3. P4, Q3, which option? I think it looks like second option. You can do this very well. If you want, I will continue further. Can you say R, quick sort? What is the answer? I think same. Quick sort having, right, two kind of recurrence relations. So anyhow, quick sort, what is the answer? N minus k, T of k plus C. I think this one, T. N minus k plus T of k plus N. I think it is the worst case recurrence where k is a constant maybe. It is the worst case recurrence relation, right, for the quick sort. Right, for the quick sort, the worst case recurrence relation. So what is the name of this one? Right, this is going to be, what is the number? I think 1. Go to the next one now. PQRS, towers of an eye. Towers of an eye, as I mentioned to you in the previous chapter, 2Tn minus 1 plus constant. Plus constant. It is going to be, what is the answer? Number 2Tn, right, 2Tn minus 1 plus 1, I think 2. So finally, P4, Q3, R1, next one is going to be S2, which is the option? B, second option. Question number 27, second option, everyone know that. What is question number 28? This one we done in the classroom also. Question number 28 we done in the classroom also. Binary search possible. Answer is log n. You verify yourself, it is there in your notes. Answer is what? Second option. Question number 28, second option, binary search. Go to the next one. Question number 29. Question number 29, please verify properly. Nothing there. This algorithm, because of small mistake done. This algorithm for the option C, for the input option C, right? This algorithm don't stop. It will go to infinite loop. Question number 29, you verify. Answer is C. The reasoning on this algorithm, if you give option C, right? So this algorithm never terminate. What is the question number 29 asking? On which one of the following contents of y and x does the program fail? Fail means it never ends. And option C, if you give, it never ends. Please verify properly. Next one, right? Next one. See this one. This algorithm on any input to do properly, right? Question number 30 C. Question number 30. Given algorithm on any input to work properly, right? Just change line number 6 to, right? Option A. Please verify once, it is very simple. Binary search algorithm only, little bit modified, some problem is came, the rectification is going to be question number 30. Question number 30, option A. Verify once. Right? Binary search algorithm only, that is the reason I am not explaining. Listen everyone now, question number 30 is binary search algorithm. Normal binary search algorithm, you know, in the normal binary search algorithm, small change done. That is the reason. Some inputs, it is going to infinite loop. Example is going to be question number 29, third option will go to infinite loop. Now, rectification for that problem is question number 30, right? Just apply the option A, right? It will be rectified on every input, it will work out. For the question number 30, this is the story. Next one, see the next one now. Question number 31. Question number 31. Please be careful. Question number 31. Right? So it is some binary search is possible. Please verify. I done. Binary search possible. Please verify. Time complexity is order of log n. Binary search possible. Please verify properly. Time complexity order of log n. Next one. What is the next one now? T1. T1. If you see the T1, right? This problem already done in your notes also. T2. T2. So this also there in your notes, please verify. T3. T3. What is the answer? T3 is, I think, let's see correctly now. T3. Right? T3 answer. Question number T3 is very, very important. That is the reason I am explaining. See, question number T3. Right? T3 answer is going to be big O of n. Which option? Second option. Carefully listen. T3, question number T3, answer is going to be big O of n. Right? So I written also option B. Some people are asking, sir, how? In core main there is a one title also. See, there is a title also. See this one. Selection algorithm. Selection algorithm. Worst case, linear time. There is a one title also. Selection algorithm, worst case time, linear time. Worst case, linear time. Worst case, linear time. One big title is there. Right? So you will divide the given array. You will divide the given array into, right, 5 parts. Divide the n into 5 parts. N by 5, n by 5, n 5. That is the reason this algorithm is also called as median of 5 algorithm. Median of 5 algorithm. Divide the given array into 5 groups. 5 groups. Right? 5 equal parts you divide. N by 5, n by 5, n by 5. This algorithm is also called as median of 5 algorithm. Another name, selection algorithm, worst case time, linear. So the everyone know what is the selection algorithm purpose? Selecting kth smallest element. You know very well. In your notes, selection algorithm we done. Selection algorithm, what is the purpose of selection? Selecting kth smallest element. Same algorithm, right? Small modification is done. Selection algorithm, worst case time, linear. Worst case, linear time. How? You will divide the given array into 5 parts. This is also called as median of 5 algorithm. Right? This algorithm will take every case order of n only. Please be careful. It is very, very important one. If you want, you can read your own. I said also, in core man, one title is there. Selection algorithm, worst case time, linear. How it is? You will divide the given array into, right, not 2 parts, 5 parts you will divide. Median of 5. After dividing array into 5 parts, in every part you will find out median. In the first half you will find out median. In the second part you will find out median. That is the reason it is called median of 5 algorithm. Median of 5 algorithm purpose, finding kth smallest element in the given array. Time complexity order of n every case. So it is very, very important one. There is a proof also there. Please go through it. I said the normal selection algorithm. This is the selection algorithm, worst case time, linear. It is a nice one, please you take care. This may come in the GATE exam also, take care. Why it is called median of 5? 5 parts is done. In every part you will find out median. So that is the right question number T3. Answer is going to be option B. Right? Fine.